There's also an audio number that's worst case. If you go up to meeting info in the top right corner,
Right.
there's a call-in number with an access code.
How about now, Kimberly? Nope. Can you send her those directions, John?
Probably.
And then if we want to go live, we can probably go live with Mike and Matt and Paulina. And so welcome back to the manufacturing and materials session of the Startup Week here from Launch Dayton. We're apologize for running a couple minutes late here. Technical difficulties, of course, during the time of COVID. During this presentation, our next to last, we're going to give you some insights into 3D printing and how it can be utilized in early stage startup companies within the manufacturing and materials space. We have the privilege of having UDRI's Matt Hoying and Michael Pratt joining us. They're going to give a little bit about their background, maybe a little bit about Fastlane and MEP, and then talk about a very specific customer journey with our containers. So Michael and Matt, we're going to take it over to you guys.
Matt, I think you're muted.
Hi guys, welcome to the journey of ARC containers, and we're trying to look at from the lens of a startup what they did and leverage some 3D printing. So we're going to share the story of a local startup that used 3D printing as a design accelerator. 3D printing can help with product design, and we'll explain how. But before we do that, let's start with introductions. Ken, you want to go ahead?
Sure. My name is Ken Schroeder. I'm one of the founders of ARC. I've also been a local law enforcement officer here in the Dayton area for about 8 years.
Paulina, do you want to go ahead?
Yeah. Hi, I'm Paulina Schroeder. I am also a co-founder of ARC Operations, and my background is in strategic marketing. I've worked in various industries, developing new markets and introducing new products.
And I'm Mike Pratt. I'm at the University of Dayton Research Institute. I'm a design engineer and additive manufacturing engineer. And I've worked with Fastlane and multiple startup companies doing design work for consumer products.
Matt, you're muted.
Okay. I am blessed to work at Fastlane. My name is Matt Hoying, part of housed in the UDRI building, but our main mission is to help small and medium-sized manufacturers to fix the problems that frustrate them. So we go into facilities that are actually producing products and look for ways to make their products better, stronger, faster. So it's a great honor to be part of this Dayton Startup Week, and I think looking through the lens of what ARC's journey is will help a lot of startups to see what the advantages are of 3D printing. So for this case study, like I said, we're going to focus on ARC containers. So Ken, you want to start us off?
Sure. So, as I said, I've been in law enforcement since 2012. Really at the main rise and now current sustained plateau of see some of the narcotics problems, the drug epidemic, as it's been labeled, and the exposure to first responders to these different chemicals, these different substances, and the old way of processing and packaging drug seizures was exposing first responders to these harmful chemicals multiple times through the process, and was also causing a lot of time issues with officers and how long it took them to safely secure and package evidence to be sent to crime laboratories for testing.
Next slide. So as Ken mentioned, you can see that the evidence collection process in general is unsafe. We try to provide a few data points for everyone to kind of pinpoint to the problem. And also the evidence collection process is very inefficient. So if Matt can go to the next slide. You will see what it takes, and I'll just let Ken maybe explain what all of these pictures mean.
Sure, there may not be enough time to go through each of those individually, but it gives you a little snapshot here of what an officer has to do once they have a drug seizure. the old part of the process of weighing it, putting it in various containers that are the process is mandated for us by the state of Ohio. And you can see here it has to go in multiple layers of packaging to reduce those chemicals, those substances from being exposed to anybody. So the process, especially as we began dealing with more and more dangerous substances, became a safety concern just for the number of times that we were exposed and the sheer amount of time that it would take. As you can see there, 45 to 60 minutes to book and process 2 pieces of evidence.
Next slide. So with that, Ken came up with a great idea in my mind of designing a container that would allow to secure dangerous narcotic evidence, or any narcotic evidence for that matter, instantly on scene, and will not re-expose officers to that substance during the evidence booking process. Additionally, the goal was to submit such evidence to a crime lab, whether it's a state or a private crime lab, without any additional packaging. So right now, they're looking at 4 to 5 layers of packaging going into a crime lab, and then once the substance is analyzed and sent back to a police department or any law enforcement agency for that matter, it has to be repackaged the same way. So this slide gives you a brief overview of idea coming to life. We first actually worked with a friend of ours who has some experience, well, actually a lot of experience in CNC machining. So he cut out this square container you can see on the picture out of a cardboard box. And then he went ahead and 3D printed it, and that's what that teal box on the left is, and designed a closure. And in the process, we learned that the manufacturing of that container would be extremely expensive, due to different specifications of manufacturing a square container, injection molding it, and having someone to assemble the lid and the base. So then it morphed into a round container, and we looked for a few products in the market that already existed, couldn't find anything. And eventually, through many rounds of iteration, we ended up with a round container that you see on the far right. And Matt and Mike, I guess Mike specifically, will share a little bit more with you on how we arrived at that iteration. Next slide. So what we have today is a container with an elongated neck that allows visual tracking of the evidence chain of custody. So when an officer finds a substance on scene, he or she would place it in a container, which is your step 1. Then it would be secured with a lid. And then when the container arrives at a crime lab, you pull a tab that drops a ring on the neck of the container and visually shows that that was opened and that officer was the only one who handled it. Now, once it's analyzed and placed back, a different color lid is used to secure it again. And the step 6 would show you that an officer secured it, hence the blue ring, and then an evidence tech analyzed it and put it back and secured it again with a red lid. So if it is to ever be reopened again, then you pull the tab as well, and the red ring drops. So right now our neck can house up to 3 rings. Next slide.
Okay, so before we jump into discovery and what that means, I wanted to kind of introduce you to, a problem statement, idea, ARC had an idea and needed a path to production. So AM was if you saw the first slide, AM is kind of the bridge that connected the idea to the actual production of it. And that's kind of where we'll focus moving forward on how that technology helped them save time, money, fail faster, fail cheaper, and then finally produce a product that makes sense in the market. So one of the things that as a startup or an entrepreneur, you have an idea, but you don't know exactly what's out there. So during the discovery, you kind of look at what are the components of the product that you're making, and then you kind of look at what is available in the marketplace and see if there's components that I can purchase that are existing out there, and then maybe there are other things that you could purchase and add on to your final product. But then there's the parts that are either the housing or something that isn't available in the marketplace, and that's when ARC Containers kind of jumped into additive manufacturing for a solution. So it's a great technology, and when there's some unique hardware that you need to design. So I'm going to turn it over to Mike for the second part of the discovery and what he did with ARC.
Great. So yeah, like Matt said, in the case of ARC Container, they started from, does a container exist in the marketplace that fits my needs? And really they came to this discovery that no, a container doesn't exist. And so when they came to us here at Youre to design that container and system with the intent they had in mind, we really discovered that there's two components, right? You have a container and a closure. And instead of reinventing the wheel, we went to the commercial off-the-shelf suppliers of containers and closures and looked to see if they had something that met the needs, and we found that a closure existed. And by using a commercial off-the-shelf closure, we were able to save significant upfront capital investment in, now we don't need a $100,000 tool to make closures. We can just buy them per part off, and the per part cost is, sufficient for them to make very high runs of their part. Now all we have to do is design a single container. And that's really where the design intent and the process began, was starting with the discovery of what exists in the open market.
Thanks, Mike. So then we saw some huge advantages to ARC once they had their design and their idea in mind. Work with a design engineer, and the benefit is you get to kind of drill down and have physical drawings, and eventually this would help you to go to a service provider, hopefully local in the Dayton area or in the Ohio area, to kind of get prices on tooling or parts or whatever you need to be making. So I just think it's important to have somebody, if it's a friend, family member, or come to us if you need a design engineer to help you draw the concept. I would say you want to have a lockdown design before you start working with a design engineer, but I'll let Mike kind of explain how he does it and how he works with startups, entrepreneurs, and others to kind of get the idea on the computer. So. Mike.
Sure. So there are, tons of design firms and engineering firms across the country, but really where the benefit comes is if you can find someone local like us in the Dayton area. There's Youre, there's several other places. If you can work hand in hand with a design engineer, maybe even sit down. I mean, I worked with Ken and Paulina at one point. They were sitting right beside me at the desk, and we were designing stuff in CAD hand in hand to get exactly what they wanted down on paper. But that doesn't come easy necessarily. As the startup, it really helps to come with some idea of what you want. While I can always work off a bar napkin sketch, having a little bit of an envision to what you want really helps the design engineer move from a mode of design conceptualization and coming up with what you want, and really into design refinement, where we can find and leverage our engineering experience to create the best out of your product that you can.
And Mike, would you say form, fit, function? Those are the kind of things that you want to kind of identify before coming there?
Absolutely, yeah. Have some, even if, I had one customer for a project one time, he literally molded something out of some plastic with a blowtorch in his garage. Like, something that gives an idea of form, fit, and function for you really helps the design engineer, be very efficient with your time, with their time and your money.
Very well said. Okay. So this, Ken and Paulina, if you guys kind of want to walk us through the iterations.
Yeah. So as Paulina kind of alluded to, the one on the far left there, that little teal container, was our first iteration. We've worked with additive manufacturing, 3D printing, the entire way through the process, because our funds as a startup were pretty limited. We didn't have investment out of the gates. A lot of it was self-funded. So we didn't have the ability to purchase a mold and see if that idea worked, and if it didn't, go back and spend another $15,000 to $20,000 to have another mold produced. We had to do very small batches of ideas and do that fairly cheaply, and 3D printing allowed us to be able to do that. So, as Paulina had mentioned, that first iteration of the square box there, the square container, was idea number one. We found out that producing that, actually getting a mold to injection mold that when it's squared, is quite a bit more expensive. And there were also parts that need to be assembled, which also cost money to pay somebody to assemble them for you. So we moved on from there, and through some help, through some research, found that the next iteration, which is that second blue container there, was the next piece that was produced. But then the idea came in for the elongated neck for actually being able to visually track the chain of custody. And that when that idea came around, that was well beyond our skill set to design, and that's where Fastlane and Mike really came to the rescue there for us. What we were able to do, and I don't know if maybe Mike wanted to speak on that further, but that gray ring there is where our relationship with Fastlane really came to be.
Sure, I can pick up from there. So I'll actually thank you, Matt. You read my mind. So what we really were able to do once we went and kind of dug in deep with the container design for ARC is we were able to use additive manufacturing to very rapidly iterate. I mean, sometimes I literally would put something on a printer, have the part off in 20 minutes, and keep going back to designing. So it gave us a quick, rapid iteration ability. After we got out of prototyping and Ken and Paulina were able to take something to their partners in law enforcement and at the crime labs to show them what they had and that it worked, they were ready to go into production, but the question arose of how to get there. And so by utilizing AM and keeping some manufacturability in mind early, we were able to make quick pivots to the final manufacturing approach. Originally, as all containers are made in the world, or most bottle-style containers are made with blow molding. That was what we thought we were going to do. When it came down to the custom container we went with, we found that injection molding was a better process for our needs. And we had to make some pivots. You can see the arrows there. I won't get too in-depth with the technical details, but we had to make adjustments to make it moldable, and going from a shoulder design to a rib design that holds those rings for that traceability on the ARC system container. And additive manufacturing gave us the ability to very quickly check those fits and functions, and that's the kind of thing that, like Ken said, can save tons of time and money. On that topic, I'll turn it back over to Matt, and he can discuss the real big impacts of AM in shortening the time and lessening the cost of getting to capital investment in production.
So thanks, Mike. This is a really good lead-in as to life with and without additive manufacturing or 3D printing. You know, what Mike explained in life without additive manufacturing, and we would have not had the neck elongated enough to where we would have liked it. We would have had to have gone back and remake or modify tooling, which is time and money. I think Ken might be able to tell you a little bit more on what he estimated as a savings, or what he would have spent had he not have used additive manufacturing or 3D printing. Do you want to kind of, Ken, walk through that journey and you know, the advantages of that, how much money you saved on, you know, not having to remake tooling, remachine tooling, and just time alone that you were able to get this thing to the end user, or to the injection mold house?
Sure. I mean, a bit what Mike alluded to there, that there were times he would be able to 3D print a part in this process within minutes. Typically, even for an entire container, maybe 2 or 3 days. The lead time just to have a mold, injection mold made is usually somewhere between 30 days up to 2 months. Starting with our first iteration, if we had had to go the route of having a mold made to have those injection molded up to our final iteration, ARC would have spent upwards of $100,000 having molds designed to produce those parts, and that's with no mistakes, best case scenario. With additive manufacturing, we've been able to do it for, I think, under $15,000, closer to $12,000. So you can see the gap there, and probably with each of those molds, if we were making them, if we were having somebody make those for us with a 2-month lead time, it could have taken us 2 years, 2 years of waiting and playing around with it, whereas additive manufacturing allowed us to do that very rapidly, understand where mistakes were, fail fast, and continue forward.
And on the lid end, if we were to actually invest in a lid mold, it would have cost us upwards of $100,000 just for a lid mold. So being able to work with a design engineer on an MVP, the minimal viable product, which is what we have now, is definitely beneficial, and again, saved us another $100,000. So we are really total in $180,000 savings.
Okay, so we started a little bit late, but we are running a little bit over time. But so once you get to that that you've got your design, you've got everything ready to go, and you're ready for production, that's when I recommend that you reach out to maybe Fastlane. We would be a partner in identifying those local resources that would help you to mass produce your product. We are unbiased third-party advisors, so we don't have any skin in the game. We just want to make sure that we recommend the right fit, right company for you guys once you get there. So real quick, Ken and Paulina, do you want to just kind of talk about where you're at now with your product, and then we will move on to questions, and then let the next presentation take over?
Mm-hmm. We're about to roll out a market test, which is planned with 5 local law enforcement agencies. We're going to partner with agencies that will determine who their proactive officers are, and those officers will be the ones using the container. We will be gathering data during the process, so they will be filling out certain questionnaires, and then we will be analyzing that data to prove our concept and the fact that it does save time to those officers and that it is a safer process. We completed the design of our website that you can see on the slide. We're also currently working with a few partners on launching complementary products within the ARC brand, as our overall brand provides safety-minded, solutions to law enforcement and first responders at large. So that's where we are. And as far as our collaborators go, we have partnered with UDRI and Fastlane. The State Crime Lab is another partner of ours. So we are testing this container with the state of Ohio.
And there's tons of local resources that you're learning this week who can help you guys out. And there's a few of them that ARC Containers said that they used. So there's a list of a few. We'll go ahead and thank you guys for your time, everybody listening in on this presentation, and we will turn it back over to you guys.
So, Matt, thank you so much. I very much appreciate it. The story of ARC's a great story. I can personally endorse Fastlane. They are a great MEP. They have specialty in additive manufacturing, and they've helped a large number of small businesses here in Ohio come through the valley of death, as it were. So, Ken and Paulina, good luck in your story. We're going to see if Kimberly actually has audio now. Can you unmute yourself, Kim? No, we're gonna have to get you to dial in. So as we're wrapping up here, Mike, I think we have your contact. Oh, there's Kimberly. Good. And so, Kimberly, we're gonna let you go ahead and take the screen and give a little introduction of yourself and IC3D. I'm going to stop talking since we're running short on time, and I'll let you take it from here.
Excellent. So let me go ahead and share my screen. Okay. Okay, can you see my screen?
Not yet. Sometimes it takes a minute.
So I've done, okay.
There we get
Let's
it.
try it now. There we
And
go.
there we see
How
it.
about this? Excellent. Can you see it now?
Perfect. We got you, Kim.
Perfect. Awesome. Thanks, guys. Sorry for all the technical difficulties. I really enjoyed the last presentation with my colleagues from UDRI, and also it's always tough to follow an amazing group. Hopefully I can do this topic justice. So my name is Kimberly Gibson. I'm the CMO at IC3D Printers. We're here in Columbus, Ohio. And you might remember the old adage that people say, if you want something made, you can either do it fast, you either do it cheap, or you can do it good. But you couldn't do all three. You pick two. Well, I'm here to tell you that with 3D printing, you can do all three. And I think that my UDRI team, the team before me, they proved that you could do it. Just a bit about IC3D, meet our team. Our vision is to expand human potential by making manufacturing accessible to all. And we are a vertically integrated shop. So we make materials. We do 3D printing as a service. We also build custom 3D printing machines. Our technology is using SEM technology, and I'll show you a little bit more about that. We also do CAD design. I'll move on. Just that we have some SBIR projects going on. We're a member of American Makes, which is our national trade association, and we are an MBE certified. So just to show you a diverse group of experience on our team, mostly from the automotive sector, and myself from government and defense. Some of our customers, we love playing in the sandbox with these folks. They teach us new things every day. So just to put in perspective what the previous group talked about was, this is a CNC Mill Factory photo. And you can see this manufacturing is not dirty, dark, and dangerous, but this is a traditional subtractive manufacturing facility where you take a block and then you mill it away. You heard a lot about injection molding. This is a picture of a typical injection mold tool, which you heard is very expensive, and you heard takes a long time. That's true. So essentially what happens is you have this tool, you push plastic inside of those chambers, and out pops a beautiful piece of whatever. Well, here's an injection molding factory, so a very modern looking injection molding factory. These folks can pump out hundreds of thousands of pieces in a week. Amazing stuff, right? So here are some examples of how 3D printing tooling can move forward. So these are, you see at the top left, you see injection molding. Injection molding is a process. It's fantastic. You can do things like car interiors, toys. Most plastic things that you have made in your life are made with injection molding. Vacuum forming is another type of process. The kiddie pools, solo cups, most of the packaging, if not all the packaging you see is done with vacuum forming. Of course, metal stamping, and then metal casting. And I'm here to share with you that 3D printing can be used to do all of these things. And I'm only going to focus on the injection molding for the most part, but I will show you some examples, real-world things that we have done. So a bit about tooling, jigs, and fixtures. So this is a picture of our beautiful lady. All of our printers have female names. This is Eleanor. She is about a 4-foot cubed 3D printer. So she's large and in charge. You can get, the banana gives you a sense of scale, right? You see the banana there in the middle? All right. This is the best side of my colleague, Matt, looking inside the printer, fixing it, so you can get a sense of how big it is compared to him. This is Michael, our CEO, Chief Extrusion Officer, pulling out a tool out of one of our large format machines. This is what we call medium area additive manufacturing. It's not the biggest, but it's definitely not desktop size. Also called MAM, and this is what you get when you let engineers name things. That's all I'm saying. Michael's holding a stamping tool for an appliance company, and Matt's sitting inside one of our printers. This is an example of a tool that does thermoforming. So essentially you print this tool out and then you take thicker plastic and you form it on top in the vacuum forming concept. I think we've gotten something like 20 shots out of this so far. This tool still looks really good. It's good to go for a long time. This tool didn't cost that much either. It was a few $100s. Some other examples of 3D printed things that are very important in manufacturing jigs and fixtures. You need jigs and fixtures for everything that's made, especially if you're assembling a car, right? A single vehicle can have hundreds of jigs and fixtures to do fit checks before the part goes on the vehicle. This particular black 3D printed object is a design fixture meant to help assemble something, make it easier on the worker to assemble something. So you can imagine assemblies inside of one automobile. You have hundreds and hundreds of these things over time. You can also print this. Now this is pretty awesome, I gotta admit. So this is an example of vacuum formed direct print. So it's both vacuum forming and direct printing. So what we did was we printed molds that formed the sides of, you can see this costume, the different pieces and parts. Then there's some things that are direct printed. And what we allowed this small company to do was to make their business more repeatable because they're a custom costume factory. And they were finding that if they needed to do 2 or 3 versions of the same thing, they were basically using all those artists and all that creativity to custom paint and mold and hand make all this stuff. With 3D printing, we were able to cut some of that out, vacuum forming, and repeat, making their business a lot more profitable. Let's talk a little bit more about functional prototypes. That last costume, which was about 6 to 7 feet tall, was also considered what I would call a functional prototype, but this is an actual device. So 3D printing doing functional prototypes in first run. So this is an example of something that went from idea to field ready. This is an actual functional product for a major customer. It includes multiple materials. What you see here on the left is a 3D printed part. That 3D part is halfway finished. You can see what we started with all the 3D lines. You gotta love it. Then on the other side, that has been sanded, primed, and painted. And you can see there's about half a dozen parts here, all of them 3D printed. And the final product here on the right. The bottom and the top are using a TPU, which is a flexible 3D printed plastic. So not only are you just using a typical 3D printed plastic that you may be familiar with, you're also be able to use flexible. So 3D printing also allows you to do multiple materials in one prototype or one functional product. In this particular case, we were able to integrate sensors. We were able to do all the electrical and all the wiring for that customer. During COVID, they happened to be at a lower production levels, and we were able to help keep this product on target as a result. You can also see inside the 3D printing, you can see some sync screws that allow you to mechanically fasten different parts of the object together. So just a really flexible platform to make functional products very quick. A little bit about volume production. Now, you've heard that 3D printing is best when it's at low volume, and we agree with that. We say we're good at hundreds to a few thousand, and then you probably want to think about injection molding. But for those first thousands, it's really 3D printing is getting better and better and more cost competitive. This is an example of a 3D print farm very, very close to ours. And here's an example of a printer that was custom built for one customer who needed, thousands of a certain part in a short time frame. So this is a 5-headed 3D printer. We call her affectionately Rosie. And Rosie is a master of 4 followers, and she's able to print in real time the same thing over and over and over again. So you can imagine a future where custom-built machines printing just that one thing can actually be competitive with injection molding and other processes. And Rosie's an example of that.
Kimberly, just real quick, I'm going to let you know you actually have until almost 3 now. We bumped it back a little bit for you.
Oh, thank you. So I don't have to go so fast.
No, you don't have to go so fast. I wanted to grab you before you went too far.
Thank you. Thank you. So I will slow it down and try to be more myself. But this is an example of what I believe is the future of 3D printing. So custom purpose-built machines, which is we're exploring more and more of that in our own practice. This is an example of low volume production. We work with an armored vehicle company that only needs a few hundred of something. And you can imagine in a situation where you're taking an existing vehicle, you're pulling all the guts out of it, you are armoring it up, and then you got to try to shove everything back in there, and their tolerances on those are very low. So you might need to redesign certain things. So we've been able to work with them to do, you know, a few, maybe 10 to 20 a month, maybe a few hundred a year. You wouldn't get the value out of a tool if you were only doing a few hundred a year. So this is an example of that. Here's an example of some more of those parts and how we would post-process them. So the part in the foreground is a dashboard piece. It happens to be a glass-filled, I believe it's polycarbonate, maybe it's polypropylene. It's been sanded, primed, and painted to look just like anything you've seen in a car. The other small round piece is a piece that actually is also post-processed. All these things are 3D printed. That piece was actually coated with a special paint to make it resistant to UV light and other things. Here's another example of how you can get a very nice automotive finish on a large part. You can see the 3D printed half of it, and when it's finished, you can't tell the difference, and it looks very good, and it's also able to be used. So the future we see for 3D printing is that, you know, those warehouses of spare parts that we all hear so much about are going to decrease. And if you're a startup, you probably can't wait to get to this point where you have a warehouse to do all this stuff. But we see a big change coming because of the ability of 3D printing to scale up production. And a whole room of these printers can alter the need for whole rooms of these other things. We do feel that they work in concert together. These digital technologies and traditional manufacturing work very close together, hand in hand, really. But if you're a startup, you don't need these factories yet. 3D printing is a real option for you. So I'm going to give you another example of an application, and my UDR colleagues do an amazing job. I'm going to give you a different example that also proves the point. So imagine that you have this device that you want, that's what we call a life-improving device, because we're all in this to change the world, right? And imagine that you need to create this thing, and it's plastic, and it's got different covers on it. Who knows what all it's made of? But you have to get it to a point where you can send it to your people and get them to buy in. You need some prototypes, you need some samples in order to take it to the next level. So here's an example of tooling costs. So on the traditional side, tooling, you heard also from my UDR colleagues that tooling is about $100,000 for one of those injection molded blocks. The cost per unit you want to spend is about $5. You want to be able to recover that cost, right? So in order to recover the cost of that tool, you're going to have to amortize that over 20,000 units. Wow, that's a huge lift, right? But 3D printing, the tooling cost might only be $2,000. And then the cost is still $5 per unit, but then you amortize it over 400 units. These are real examples from our business. So you don't need to pre-sell as many units if you can do this with 3D printing, or you don't have to raise enough capital for the tooling. So we believe that 3D printing in this way is democratizing manufacturing for everybody. This is another example of that same thing. So in traditional tooling, you know, the cost goes down with the higher number you get because you're using tooling. But in 3D printing, the price of one direct 3D print is the same as, you know, 100 or 2,000. It doesn't matter to us. So really, when you think about 3D printing, what you end up doing is you print a tool, then you maybe get 200 shots out of that tool before it degrades and you can't use it anymore. Then you print a new tool, and then you get another 200 shots. And in between, you can redesign. You can listen to what the marketplace has to say. You can make some small design tweaks and still never hit that, don't have to have a new tool to do it. And we believe, so in that way we believe that 3D printing, while it won't fully replace traditional manufacturing, but it definitely augments it, speeds it up, and makes it more nimble. So a little bit, I wanted to share with you briefly about our COVID response because it's very relevant here. So IC3D, on the very early days of COVID, began production of face shields. And what you see on this table are furloughed workers working. We hired them to scale up our production. You see 3D printed fixtures on all those tables to seal the glue and the adhesive on these visors that ended up being face shields that you see here on the right. Just to give you an example of how fast this happened. So we heard about the announcement about COVID, right? Late March, like the 21st, 22nd, something like that. We knew that there was something we could do. So we connected with our local veterans health system in Central Ohio. They have a 3D printing lab. They also had a pulmonology team. They said, hey, we need face shields and face masks. What can you do? We said, we're not comfortable with face masks, but we can do the shield. Here's a design. We showed them the design. We iterated. And within 3 days, that design was exempted by the FDA because it was a general product. It wasn't a specific medical device. It was approved by the NIH. The Veterans Health Administration had made an order, and we had open sourced that design on the website so that anyone can download and print that across the world. Our filament, which is a PETG filament, was used to manufacture those. That was also approved as a viable polymer. We worked with our National Additive Manufacturing Institute, America Makes, to kind of smooth the glide path. But imagine going from design to regulatory approval in 3 days. I mean, that just never happens, right? And I hope that we never have a pandemic where that has to happen again. But the story I'm sharing has happened all over the country. 3D printing was able to respond more quickly than any other type of manufacturing. So one of the things that we did, we knew we didn't have enough capacity in our machines to meet the need in the early days of COVID. So we organized a make force of 175 individuals, people at schools and companies who had 3D printers, people who were either stuck at home or had a whole lab that they could use. We gave them the design. We sent them filaments. Some cases they used their own. They printed these visors and they gave them to us. We organized a supply chain, put these visors together, and then sent them out. Over 60,000 face shields were produced and contributed directly to the state of Ohio strategic stockpile of PPE. We're really proud of that, but I think what it showed us is that 3D printing as a distributed manufacturing tool is real, and I mean, we're so excited for how this has changed everything for 3D printing. I want to share with you another story because one of the things we've done as our annual philanthropy, this will be the 3rd year, is Toys for Tots. And this charity event is what allowed us to know that we could do this distributed manufacturing experiment with the face shields for COVID. Last year, we had 65 makers all across the country, people with 3D printers. We sent them filament and we sent them a design for toys, and they 3D printed the toys and sent them back to us. We were able to then take those toys to the U.S. Marines to be distributed all over. And that was the first test of this distributed manufacturing system, this virtuous system that we created. And I guess you can probably tell how passionate I am about it. So I really feel like we've tripped onto something wonderful, and that for you as startups, 3D printing is definitely a tool in your arsenal to get your product to market. And there are lots and lots and lots of 3D printing providers. Ohio is one of the highest concentrations. So you're in a really lucky place, especially being in Dayton. There's a lot of great partners all across the state. Lots of options for you. And no, just Google 3D Printing Ohio and you can find it. So I just want to say thank you, and I'm excited to take any questions that that anybody may have. So I'll stop my screen share here. I can figure out how to do that. There we go.
So Kim, we had to transmit the live stream through the social event. There were no questions for the group that we were able to capture back, and we don't know if that's technical difficulty or not. But we are going to wrap the session up. So thanks so much for Kimberly, Matt, and Mike. Thanks so much for joining us. I think that these are going to be archived on the internet, so you guys will be able to see yourself at some point. And we very much appreciate you supporting the community. Thank you, guys.
Bye, Matt. Nice to meet you.
Nice to meet you, Kim. Take care.
You too. Okay. There were no time for questions. All the technical difficulties. And